Welcome to our Power Electronics project. We are group number 4 from the Department of Electrical and Electronic Engineering SAS. We are currently in our third year second semester. In this video, we will showcase our project, the development of a stepped motor control system. Stepped motors are widely used in robotics and automation due to their precise control capabilities. Our project focuses on designing a system to control a stepped motor speed and direction using Arduino, L298 Motor Driver, and push buttons. To build this system, we need the following components: Arduino Uno, L298 motor drivers, 10 kilo ohm potentiometer, push buttons, system into 2 LCD display, stepped motor, power supply of 12 volt. Then we need to connect the components, and you can see it from the circuit diagram. We will give the pin connections and description of everything in the description link. We simulate the system using Proteus and MATLAB Simulink to verify its functionality. The Arduino code that makes our stepper motor function seamlessly. The code is structured to perform three main tasks. First, reading input. Second, processing data. And third, controlling the motor. On the section of reading input, the potentiometer values control the motor speed, while push buttons determine the direction or stopping. On the other hand, processing data, the speed values is mapped to a percent 0 to 100% and displayed it on the LCD. And third section, how can we control the motor? The L298 motor driver receives signals based on the 4-step sequence to rotate the stepper motor accurately. Here, how the loop works. First, the potentiometer value is read and mapped to control the stepper motor speed. Then we check which button is pressed, clockwise, anti-clockwise, or stop. Based on it, the motor rotates accurately using precise pulse signals to the L298 driver. And the LCD updates in real time showing speed and direction. Here we are using Proteus to simulate tools that allow us to visualize and troubleshoot our circuit before physically building it. After testing our circuit in Proteus, we moved to Simulink to analyze the system at a higher level. Simulink is a graphical programming environment that allows us to model, simulate, and analyze dynamic systems, including motor control applications. In our Simulink model, we used several key blocks to replicate the behavior of our step motor control system. First, on analog input block system, we represent the potentiometer input for speed control. Secondly, on the push button blocks, we simulate the user's input from motor direction. It can be clockwise, anti-clockwise, or stop. On the third section, on digital output blocks, we sense control signal to the L298 motor driver. On the fourth section, we used a stepper motor model to simulate the real behavior of the stepper motor. On the other section, we used display blocks. Here, we show the real-time speed and directions of the output. Using Simulink, we implemented a pulse width modulation control mechanism to precisely control the speed of the motor. The simulation allows us to observe the motor's behavior under different inputs and ensuring that it represents correctly to speed adjustment and direction changes. We also analyze waveform to check the response time and accuracy of our motor control system. This helped us fine-tune our control signals, reducing delays and improvement overall efficiency. By testing and Simulink before hardware implementation, we were able to detect potential timing errors and optimize motor performance before real-world execution. After successfully simulating our stepper motor control system in Proteus and Simulink, we moved on the hardware setup to bring our project to life. For the hardware implementation, we carefully assembled the following components: Arduino Uno, L298 Motor Driver module, stepper motor, US17HS4401S, 10 kilo ohm potentiometer, push buttons, 16x2 LCD display, and 12-volt power supply. We also used some jumper wires and breadboard. Once all components were securely connected, we uploaded our Arduino code and powered up the system. As expected, the stepper motor started responding to button inputs and potentiometer adjustment. The LCD displayed real-time speed and direction, confirming that our setup was working perfectly. Thank you everyone for staying tuned.